So what I want to show you today is a live working demonstration of CDM in action, including tokenized settlement. Okay, we'll talk a little bit more about that in a minute. This is going to be for a repo trade. So relatively simple, straightforward securities financing transaction, but using all of the data structures that Tom very eloquently was explaining. And whereas he was showing you the rune code, what we'll be showing you is how we effectively drive that model with automation. So before I do that, I just want to introduce you to what you're going to see, because if you're not used to CDM or you're not used to a repo trade, then it's a useful contextual background. So just very briefly on Tokenovate. Tokenovate are a deep FinTech company based in the UK. We've been going for 3 years, based in Cambridge and London. Everything we do in terms of developing technology is building technology around CDM, okay, as a common data standard. And what we are doing for the industry is we're providing technology to automate post-trade, okay, for OTC bilateral derivative trades governed by ISDAs, and for securities financing trades governed by GMRAs and GMSLAs. And really, as you've heard probably from more than one person, CDM is about bringing together data, a rich, complete set of data in a structured format, and then enabling you to manage the rights associated with that trade, the legal rights, the economic rights through lifecycle. Our technology effectively has it has 4 key components, but the 3 components you're going to see today are the ability to connect a trade to the CDM model. So this is about taking data from OMS platforms, taking data from sort of infrastructure platforms like Calypso, like Murex, and then bringing that data in whatever sort of data taxonomy that is into CDM. That brings it in line with the standard. We're bringing in the legal frameworks, the ISLAs, the GMRAs. You saw that in the last session in room 1, if you were there, where ARC 51 was talking about bringing in the CSA data, the collateral eligibility data. And then we're using the technology that we're building to effectively automate the change of state of the CDM model. So the CDM model is a state-based model. That data can be transformed over the life cycle. And one of those, one of the end processes of that automation is, of course, settlement. So the actual movement of collateral assets or the final settlement of cash payments. So this is what you're going to see. And the work that we've done is to create a product agnostic trade automation process. So CDM is a really powerful framework for post-trade automation because it is asset and instrument agnostic. And that is not the way that capital markets are set up today. They tend to be siloed. People build technology out in those silos, and the static data sets reflecting the different asset classes or the different instruments are built like that. CDM is different. It's kind of like completely orthogonal, and it allows a level of composability which is super powerful. And that's what we're really leveraging here. Now, we're going to come back to this when we talk about settlement, but tokenization is something that I'm sure you've heard a lot about. Tokenization is quite a misunderstood construct, and in many ways, it's created a problem for itself. The reality of tokenization, as you may have heard from my colleague Ian, is that there are multiple different technologies on which tokenization can happen, and there are actually multiple different legal frameworks by which the token that is created can be created. And this is a problem for the industry because what you end up doing is you create parallel workflows. So you have a workflow for traditional assets and then a workflow for digital assets. Now, if you look at the actual volume that's traded in digital assets today, yes, it's growing, but frankly, it's minuscule. absolutely minuscule compared to the capital markets and compared to the use case. Okay, the real use case for tokenization is in collateral management. It's in initial margin and variation margin for derivative trades, and that volume is in trillions. Okay, what is currently happening in digital assets is very, very small. So how should the industry transition? Well, if you could flick a switch and switch to digital assets instantly overnight, then happy days, but that isn't going to happen. That's a journey, okay? So our thinking and our approach is to say, let's come up and create a stepping stone whereby we bring together those two workflows. And that stepping stone is to basically create a process of what we call tokenized settlement. So we are creating a digital twin of an asset, just like you would do if you wanted to create a digital twin and make that transferable. But our digital twin is created solely for the purpose of settlement, and as such it doesn't actually create a security in law or in regulation. And what that means is that you can bring the settlement, you can bring the benefits of tokenization in terms of atomicity of settlement on chain, whilst respecting the processes of the off-chain settlement process. And we'll see this in action as we go through the demo. So what I'm going to show is a repo trade, and it's going to be an intraday repo trade because I want to show this live. So it's actually got to have both legs of its trade settled. So we've got a couple of hypothetical hedge funds here, one of them called Northbridge Asset Management and the other one called Rivergate Partners. Northbridge is going to have the bond. Rivergate Partners is going to be the buyer of the repo, so it's going to be receiving the collateral and paying the cash. And it's going to be intraday, so we're going to do it for a few minutes. But CDM, as you'll see, handles the calculation of the repo amount. And again, for context, the technology that I'm going to show you, I'm going to flip between a few different screens. The important piece of the technology is our technology, which is the CDM-based technology, the workflow. But in order to demonstrate this, I'm also going to show you a couple of pieces of a couple of interfaces, which are hypothetical interfaces that we would create accessible through UPI to effectively map to an OMS platform, map to a venue, map to a technology where trades are created. And I'm going to also show a CSD. So that is effectively the way that we would connect to a State Street, to a DTCC, to a Clearstream, something like that. And also, for the purposes of the cash leg, a connection to a bank. Okay. So let's get into this. So the Tokenovate technology, this is the platform. And we have effectively a list of trades that we've done before. I've put a couple of these in the system. And what I'm going to show you is effectively how this trade gets created, how it steps through the different stages of its life cycle, including the initial purchase and then the secondary repurchase. And we're going to do this live. And again, just before I do that, it's important to understand the nature of how we think about entities within our technology, because everything that we're doing has to be driven by entities and the relationships between those entities. And those are governed by the underlying legal agreements. So when we would be onboarding, or when whoever's using our technology is onboarding their clients, effectively they would be onboarding them initially with the legal agreements, the GMRAs, the GMSLAs, the ISLAs. And the onboarding process there would effectively trigger the creation of a relationship between those entities. It would also, at that point, bringing all the data relating to the collateral eligibility. Okay, so let's have a quick look now. We'll go to the first of all, we'll go to the bank. So we've got a bank account, Rivergate Partners. I've pre-populated some cash in here for these parties in different currencies. Again, this is effectively the API to a bank account. Okay, we've created a hypothetical brand called Asset Nova. And we also have an Asset Nova branded CSD as well. So again, this is effectively where the bond, so this would either be a custodian or a CSD. And I've got some bonds in here, which I've created in the past, but I'm also going to create a bond on the fly for you as well. So we can show that this is really real and not made up. Okay, and this is effectively our API portal to the system where you do the trades, so the trade instructions, but it's also the way that we onboard assets. Okay, and again, so those last three screens, they're not part of our technology, but we've built them for the purposes of the demonstration. Okay, so first of all, let's create a new bond. We said the bond seller is Northbridge. Let's make this a US bond. I'm going to give it a made-up ISIN. Let's call it, there we go. And let's say that there is 700 million of this bond. And this bond is going to be called, what should we call it? Let's call it Hot AI Company. Hot AI, 4%. So where are you selecting the underlying? They would. So what there would be a feed. There would be the connection. If you remember back to the second slide, we had a connect to CDM. So this is effectively the framework whereby we connect to CDM. Okay, I'm just using this as a manual input in a simplistic form, but this would be an API connection to that bond. So we're going to call it Hot AI. Not easy to do when you're holding the microphone. And let's say that this is a December 30 bond. There we go. So we'll give it a maturity as well. To deck 30. There we go. End of deck 30. Okay, Hot AI 4%. There we go. So I've just deposited that asset in the account. So let's just go back and check. There it is. Okay, so that's the bond. This is the bond we're going to use in the repo trade. Okay, I've got 700 million in there, and I know I've got enough cash in my US dollar account from the other side as well. So let's get into the repo trade. Okay, so here we're going to connect. This is where we effectively connect to an OMS platform for repo trades, and as the seller is Northbridge, the buyer is Rivergate, and I'm going to give this a trade number. Let's going to call it trade 7. There we go, and then the time frame. So let's go. What time is it now? 18:19. So let's call that 18:23, and then we'll settle this one. 33. We'll settle it on 18:32. Actually, let's make it 18:34. There we go. We're going to do the Hot AI bond, which should be down here. And then we're going to do 375 million of that. Okay, so that's the notional of the bond. Now the cash is going to be a little bit less because in practice, we would have some kind of haircut on that bond. There we go. And then the repo rate. So if this were a normal GC bond, it might be overnight rate. Let's say that this bond is a bit special because some hedge fund wants to sell it against something else. So let's call that a 3% rate. So it's got a special rate there. And 23. So there we go. Oops. I've got the timing wrong. Here we go. 24. 34. Okay. Send trade instruction. Okay, so I've sent that trading instruction in. Before I do that, and this is where it comes to CDM. What's happened here is we've effectively created a CDM object for that bond, just like the CDM object that you saw previously. But this CDM object relates specifically to the bond that we've just created. It has all the sort of the terms and the data that we need to look at the trade. So now, if I go to so we go back to our Tokenovate technology, and here's the bond. Okay, so this is the bond that we've just put in. So we created the bond. We effectively pushed the trade in the repo. Remember, it was 375,000 on the bond, 365,000 on the cash leg, and 3%. And this is where we start to get into the automating the workflow. So the CDM object has effectively been brought into the platform. Now, one of the things that I don't want to get distracted on, but we are using a blockchain here. And as you may have heard on previous sessions, the CDM model is eminently suitable because of its statefulness. And the similarity between the statefulness of the CDM model and the statefulness of the blockchain is very powerful. And what that allows you to do is to create a record of each of the workflow steps and record that down on the blockchain. So that's what we're doing. We're taking effectively a Merkle root of that data object. We're not putting the whole data object on the blockchain. That would become too large and too unwieldy. We're creating a Merkle root, which we then privatize, and we put that on the blockchain. And so what we end up doing here, as we step through each of the workflow steps that the CDM model enables, is we create a really rich, high-fidelity record of everything that's happened in this workflow. Okay, so it's like a truth machine, if you like. So that is the execution. The contract formation, that's the second step of the workflow. Again, this is automated we're using a Temporal engine. In fact, Temporal is a piece of open source code. They've got a booth out there. And we've tied that technology into our event management to effectively drive the movement between each of these events. And the contract formation stage is where we're bringing in the GMRA data. And so if I go down to the bottom of this object, somewhere near the bottom, there should be the legal information relating to the document. Where is it? Yes, there we go. So that there is a block of data relating to the underlying GMRA agreement. Okay. Okay, so I think I've got 1 minute before the first leg of the trade happens. So any questions while I'm waiting for the first leg to go? No? Okay. Exciting, watching it in real time. It's actually real. It's going to happen. Well, I should say it won't happen, of course, if there aren't enough assets in the... Oh, it's happened. Look at that. Yeah. It would have failed if there would be insufficient assets at the custodian or insufficient cash at the bank. Okay, so here the CDM object has been updated for that transaction activity, and if we have a look, this is where the tokenized settlement comes in. So what we have here is effectively a process whereby we are minting, settling, and burning tokens. Okay, so the first thing we do is we go out to the CSD or the bank, and we say, we know we've got a settlement instruction driven by CDM. We know the quantum of that settlement instruction. Does the party for each leg have the necessary assets to settle that transaction? If they do, then those assets are put on hold and they're effectively immobilized. Okay. Once that immobilization process has happened, and we have received that information back from those parties, we have an atomic settlement process whereby the assets are swapped between the parties, and there's a record of that on chain. We're then going back out to the off-chain books and records, the bank and the CSD, saying, you know, that settlement has happened, please move the assets off chain. Those assets are then moved off chain. And then once we have receipt of that information, then effectively the token is burnt. So that single use token, tokenized settlement, that's the workflow, that's the process, that's how it happens.
A question here.
Yes.
For this workflow, for this kind of repo settlement, straightforward one, so a simple workflow.
Yes.
How do you make a more complex one?
So there are the asset and the instrument agnostic nature of CDM effectively means that there are a defined number of events that can happen within the CDM model, and they get more complicated. So something like you would get a reset in an interest rate swap. Yeah, and the resetting in the interest rate swap would mean that you have to go out to an external data point, bring that data point into the model, and then from that data point, you can then derive, and the CDM calculation can do this, the settlement amount.
So you have created these workflows based on the
Yes.
kind of CDM events that are possible.
Yes, that's right. So the CDM model defines what the events, what the range of events possible are, and we've written effectively code which actually sits on top of the CDM model. So out of the box, the CDM model it's not a runtime model. Okay, it has logic within it to do the calculations, but it has to be poked, if you like, to use a non-technical term. And so what we've done, and you may have seen, there was an announcement with ISDA today, actually, that came out. So we're working with ISDA to effectively expand the library of CDM to create a layer of what we would call action functions. So just using your reset example, simple thing there is we know the CDM model can handle reset, but what the CDM model can't do out of the box is go to an external oracle and get that data point. So we need to write a function that says get reset data. Yeah, and then we need to write a function that says calculate reset amount. Yeah, and CDM can be driven off of those functions, but it doesn't go out of the box. So what we're doing as a business is making CDM go out of the box. Yeah, and so what we're going to look at now is we've just seen these are the steps, and this is the cash, this is the bank. So we saw that 1824, £365,000, there was a hold on that. That asset was immobilized, and that asset has now gone from the bank account.
Where is the logic represented to say that there isn't enough funds?
Well, that's a negative workflow step. So what would happen is that the workflow step would be broken. There would be some kind of notification back to the parties involved that says, you know, insufficient funds available, and then that would have to be corrected, and then you can restart the workflow. Okay.
So it doesn't necessarily cancel the workflow, like where is this?
No. So what I'm showing you here is the happy path. But obviously, there are situations where you do have an unhappy path, but the workflow would stop, and then it would have to be capable of being restarted once that's been corrected. So you're always going to have situations like that, yeah?
So the unhappy path is other interruptions, I guess?
Well, the unhappy path is you haven't got any money, haven't got enough money. You know, it's like when you're trying to go and buy a beer on your debit card and actually there isn't anything there, yeah? It will stop.
What you're describing is I'm still kind of trying to understand. So you described having.
Sorry?
You described having.
Yeah, I'm talking about, yes, our technology handles unhappy paths as well.
Oh.
Yeah, but I'm showing you the.
Okay. And then is that also code you have written?
Yes. Yeah, well, for full transparency, it's code we're still writing. We are, you know, on the journey here with CDM. We haven't written everything. We haven't written every workflow function, and we haven't written every unhappy path function. But that is, we know that.
So within the CDM, the event model expects you to go propose an event and then accept or reject the event. That gives us a framework to manage breaks. So within the decision of going from propose to accept or reject, that's when we're checking the balance. That's when we're going to the CSD. If that comes back and says there's nothing there, then the response back from the system is reject that event. And then reject event can then trigger another process, which might be, go put some assets in the box, put some cash in the box, call up the user and tell the user the system is stalled because this process was rejected. So
at that point, though, there needs to be these roles, like roles are side A, and then side B you cannot be roles as it goes from point to point. Then at that point we need to say, by the way, empty is
So anything that's required in the real world can be modeled and then
Yep. So just looking now at the CSD, just to show that the same thing has happened on the other side of the trade. So effectively, we have the bond 375 million being held. There's an immobilization of that bond, and then that bond has now been debited and sent to Riverside. So I'm logged in here as one party to the trade, but if I could in theory log into the same interface with the other side, and you'd see both the monies coming in and going out, but we didn't think that was really necessary. Okay, so let's go back. So we're going to wait another 2 minutes, I think, for the repurchase to happen. So let me just show you behind the scenes while we're doing this. So to look at the actual workflow steps itself. So if I have a look at workflow ID, starts with TR7. Oh, wrong one. Trade ID. There we go. Starts with. Okay, so what's happening behind the scenes is a lot more granular in terms of the actual workflow than we're showing in the front end, where we only have those 5 steps. But there is, if we look down at the workflow step itself, you can start to see, again, all of this is in CDM format, the granularity of the information, and each one of these individual workflow steps, the data sets here are recorded as a Merkle hash on the blockchain. Okay, so this is where you start to get that really rich, sort of granular down at a machine management level, the data being kind of recorded in each step. Okay, so let's go back now. So we've got 1 minute to wait. Any questions? Taking any questions before we?
Quick questions. How all of data is stored?
How is
All the data is stored?
how is it stored? So these CDM objects, you mean? So these CDM objects are stored in our databases. That was what, S3 databases, is it? Yeah, they're stored in our S3 databases. Everything running here is in the cloud. So we're storing these data objects in those databases in the cloud. We're using AWS, but we're cloud agnostic actually. So we could move this to another commercial public cloud, or we could run it on an individual institution's private cloud as well. And then the Merkle root is stored on a public permissionless blockchain. Okay, so the power of that, of course, is that over time you build up this high fidelity record on a public blockchain where somebody with the right keys can effectively unlock that data, come back into our database and pull out that CDM object. So you can see exactly what the data was in that object at that time and who's been involved and what workflow step is in. Oh, look at that. Lovely. And there's the second leg coming through as expected, exactly the same process. That sort of balance, check and hold, mint the token, settle the transaction on the chain, update the off-chain records, and then burn the token. Okay. And then once that's happened, the workflow engine knows that this is a repo trade. It recognizes the repo trade from when it first came into the CDM object. It knows, therefore, how many steps or how many events there are going to be in the repo trade. And so once that repo trade has reached its last step, the trade is then matured. Okay, and there is a data object created to reflect the fact that the trade has matured. And yeah, that is it, really. We think it's very cool. Yes.
So once the repo transaction is executed, then the traditional bond amount is booked and then minted. Minting tokenized bond, then atomically swapped, and immediately after the settlement is conducted, then the tokenized bond is back to traditional asset.
Yes, absolutely.
The repo transaction executed, that the mint and bar process is conducted. That is the assumption.
Every
time repo transaction is executed,
yeah.
mint and bar
Yes.
process
Every time. Yes, absolutely. Yes, yes. And this isn't just relevant for the settlement in the repo. We can use the same process to move collateral for an initial margin, for a variation margin, for a reset settlement payment, for a final payment at the end of a trade. It follows exactly the same process. But the real power here is bringing together the digital asset world and the non-digital asset world, because this process can work for digital assets. It can work for non-digital assets. You can have a bond against a stable coin here. We can follow the same process, right? And so you're removing the bifurcation that exists today. So you're allowing the digital world to adopt. Okay.
Is it possible to tokenize the bond can exist longer period of time?
Well, so yes, of course, you can do that, yeah, and actually we've used our technology to do that. But the challenge is not a technical one. So tokenization effectively has three pillars. It has the technology, okay. It then has the legal agreement, and then it has the commercial framework, okay? And you have to have all three of those. And the problem is that there are so many different technologies on which you can create tokens. There are so many different approaches to creating the token itself, okay? From a natively digital asset at the kind of the more sophisticated end, of which there are virtually none today, I would add, to beneficial interest in trust, tokenization of digital twins, and then all kinds of flavors in between, right? And the problem is that if I've created one of those tokens, I want to give it to you as an initial margin or variation margin, your risk, your legal teams, your regulatory teams say, no, I'm not taking that. I don't want that. That isn't sufficient. That isn't eligible collateral. Yeah, and this is a problem, right? There are too many people out there, are too many different approaches, too many different technologies, and therefore you can't get the flows into these assets that the use case would really suggest should be happening. Yeah, and until you can break down those barriers, you won't see the growth in digital assets that you really should. Yes, and look, if once we get to a world where digital assets are every asset that is out there is a natively digital asset on a chain, you probably won't need this approach at all, right? But that's a long journey. Okay, thank you very much.